We're going to finish up our work on conic sections by looking at hyperbolas one more time. We're going to look at some examples where we're not just graphing, but where we're given different information about the hyperbola and see what else we can find. So, for example, here is a hyperbola, x plus 3 quantity squared over 9 minus y minus 5 quantity squared over 4 equals 1. And the four things that we can get just from this equation are the x-coordinate of the center point is -3, the y-coordinate is +5, a is a value of 3, and b is a value of 2. So we need to put it in standard form, which we've done. We need to determine if the hyperbola is opening vertically or horizontally. We can see from the fact that a is below x and x is the positive term that it opens horizontally because of the x. We already identified the center. The center point is -3, 5. Now we need to identify the endpoints of the horizontal axis, which will be our transverse axis or the major axis. And so that's going to go from -3, a distance of a to the right, and a distance of a to the left. So we'll have those endpoints being at 0, 5 and -6, 5. We'll identify the endpoints of the vertical axis or the conjugate axis, equivalent to the minor axis that we found in the ellipse, and that's a distance of b up or down from our value of k, which equals 5. So 5 plus 2 and 5 minus 2. So we'll have those endpoints be at -3, 7 and at -3, 3. The endpoints that are along the vertices for the horizontal axis, which is our transverse axis, are going to be our vertex points. We locate the foci by c squared. Remember, c squared is a squared plus b squared. Here, a is 3 and b is 2, so that's 9 plus 4. C squared is 13, so c would be the square roots of 13. The foci then, since our transverse axis is horizontal, we'll go from the value of h to the right square roots of 13 and to the left square roots of 13. And the equations for the asymptotes, as we saw when we practiced our last hyperbolas, are going to be k plus, here we have horizontal, so that's b over a times the quantity x plus 3. The other one will be 5 minus 2/3 times the quantity x plus 3. And there's the point slope form as opposed to using some algebra on it and cleaning it up. And again, the point slope form is fine for me. If you want to give your equations of your asymptotes in this form, not a problem. So here's another example. We have the quantity y minus 2 squared over 36 minus the quantity x plus 1 squared over 49 equals 1. It is already in standard form. The hyperbola will be opening vertically because y is the positive term and y is listed first. Our center is -1, +2. That's h and k. The endpoints of the horizontal axis, which is going to be our conjugate axis or equivalent to the minor axis, are going to be a distance of 7 to the right or to the left of our h value of -1. So those points are 6, 2 and -8, 2. The endpoints of the vertical axis, which is going to be our transverse axis, equivalent to the major axis, are going to be a distance of 6 above y equals 2 and below y equals 2. So the coordinates of those points are -1, 8 and -1, -4. Again, that is going to be our transverse axis, so that will be the coordinates of our vertices as well. We'll locate the foci once again, and we need our value of c, which is the square roots of 85. We're going to add that because our foci are going to be on the vertical transverse axis. We need to add and subtract that value from our k value or from our y coordinate to the center point. The equations for the asymptotes are going to be 2 plus 6/7, which is a over b in this case, times the quantity x plus 1, and 2 minus 6/7 times the quantity x plus 1. Finally, let's work this example. It is not in standard form, so we need to take the steps to put it in standard form. We have a very hard time locating these four values unless it's in standard form. It's very easy to find those values when it is in standard form. So we're going to put our x terms together, our y terms together. We're going to factor out what they have in common. We're going to be very careful about completing the square, making sure that we are adding the correct values or subtracting the correct values on the right-hand side of that equal sign. We're going to divide through by 100. And so here's what we get. This actually should be equal to 1, not equal to 100. That's an error on this slide. So when you write that down, make sure you write that as equals 1 instead of equals 100. Now it is in standard form. We can definitely tell if it opens vertically or horizontally. Because the x term is positive, it's going to open horizontally. We can easily identify the center, which is 2, -1. As a matter of fact, we can also easily identify a and b. We can see that a is 5 and b is 2. And we can identify the endpoints of the horizontal axis by adding that value of 5 to our h value. We can identify the endpoints of the vertical axis by adding the value of b to our k value. So that's very easy to do. We know how to do that by now. Since we open right and since we open right and left, since our transverse axis is horizontal, then those 2 points right here are going to be our vertex points. So we're going to locate the foci once again. We find the value of c is the square roots of 29. We're going to add that to h and subtract that from h because we have a horizontal transverse axis. And then we find the equations of the asymptotes just like we did before. Our k value is -1. B is 2, A is 5, and so we just write those down. Those are our two equations of our asymptotes. So that's it for conic sections. Come to class next time and we'll practice more on hyperbolas.